On October 4th, 1957, at 22 hours, 28 minutes, 34 seconds, a two-stage intercontinental ballistic missile R-7, military classification 8K71, encyclopedic name Sputnik, launched the first artificial Earth satellite, AES, into space. This launch became the beginning of the space age of humanity. The satellite flew for 3 weeks, transmitting beep, beep, beep signals. And these signals could be heard by all radio amateurs in the world. We see it in our museum. It is a model satellite, but in appearance, it fully corresponds to the original. The first artificial satellite and launch vehicle were designed under the guidance of a development engineer who will come down in history as the father of practical cosmonautics, a former student of the Kyiv Polytechnic, Sergiy Koroliov. Our student Sergiy Koroliov, he studied here, at KPI. The ideas of creating the first satellite, the first spacecraft, the first manned flight into space, spacewalk, all these belong to Koroliov. Cosmonautics has an infinite future, and its prospects are boundless, like the universe itself. Sergiy Koroliov. Aircraft designers Igor Sikorsky, Alexander Mikulin, Alexander Kudyshev, Dmitro Grigorovich, Konstantin Kalinin, Arkhip Lulka, conquerors of the outer space. Sergiy Koroliov, Volodymyr Chalomy, rocket scientist Dmitro Tomoshevich, Lev Lyulyev. Many outstanding Kyiv Polytechnics devoted their lives to aviation and space developments, which forever changed the history of mankind. Kyiv Polytechnic Institute is the alma mater of outstanding creators of aviation and rocket technology. The quality of engineering training is valued all over the world. The Kyiv Polytechnic Institute has been and remains the innovative platform where fundamental engineering knowledge and challenging scientific ideas related to space exploration are successfully combined.
KPI для нас в Україні.
For us in Ukraine, KPI is a spiritual and scientific cosmic mecca. Because Sergiy Koroliov, Boris Baton came from here, they are iconic people in space science. Nanosatellites. It was an ambitious and, at first glance, unrealizable dream for a Ukrainian university to create its own satellite and launch it into space. No one had ever designed such devices in Ukraine before, but KPI began to design a satellite of the CubeSat format. CubeSat is a type of small satellites intended for scientific space research. They are comprised of standard cubic units. Each of these units has the size of 10 by 10 by 10 centimeters. The mass does not exceed 1.33 kilograms. In terms of their characteristics, CubeSats are in no way inferior to their large-sized predecessors, but they significantly reduce the cost of launching into a near-Earth orbit stage and practically do not cause the accumulation of space debris. These features explain the global trend in space exploration based on CubeSat. A small box weighing only up to 1 kilogram, it can perform all functions of a large satellite. That is, it can independently navigate in space, as well as receive and transmit data. Having joined the global trend in space exploration in 2009, students and researchers of 6 faculties and institutes of the KPI began designing their first nanosatellite, Polytan 1. Faculty of Heat and Power. The frame structure, temperature control means. Faculty of Radio Engineering, a system for transmitting and receiving information. The Institute of Telecommunication Systems, a teleport for receiving and transmitting information. The principal mission of Polytan 1 consisted in testing the satellite and subsystems functioning in the outer space, their interaction, and working out the most important commands. It was a challenge aimed at the showing before the whole world of our capability to create the platform that really was the first Ukrainian nanosatellite. 5 years later, Polytan 1, together with 36 university satellites from 17 countries, successfully entered low Earth orbit. At the moment, the satellite is flying over us. It emits telemetry data in digital form. We can see the onboard temperature, battery charge, and analyze the information received from it. The designers gave the satellite a maximum of 1 year of life in space. However, it has been in orbit for 7 years. Polytechnic 1 became the record holder. None of the 36 satellites of the other countries have lasted so long in space.
Ми пішли не шляхом.
We did not follow the way of buying something or other affordable and composing the parts as an amateur design. Instead of this, we elaborated the components of each subsystem and achieved their mutual coordination. This is what we were able to do very successfully. The success of the first Polytechnic was the impetus for new scientific projects. At KPI, work has begun on the second apparatus. Polytechnic 2 was twice as large and heavy as its predecessor, entered orbit from the International Space Station, having its own scientific mission. Polytechnic 2 is a payload project, an international project. It was launched to measure the concentration of atomic oxygen in outer space. The satellite has fully completed its mission. And then, the scientists of Kyiv Polytechnic took up the third satellite, Polytechnic 3, intended for Earth remote sensing, environmental monitoring, earthquake prediction, and ionospheric research. The third Polytechnic will transmit images of the Earth. It will make photos and download data to the Earth. This satellite is different in that it will have an additional unit and an installed camera, as well as extended solar arrays that are used to increase the satellite's power supply. Engineering model of Polytechnic 3 is at the testing stage. This is the test facility for testing and calibrating the positioning and stabilization system of nanosatellites. It is made of 3 pairs of mutually perpendicular Helmholtz coils, which makes it possible to create an internal magnetic field, both stationary and dynamically variable, and perform testing of magnetic coils and flywheels, integrate them with sun sensors, install a solar simulator, and fully carry out the entire working cycle of the nanosatellite positioning system. Scientists from Poznan Polytechnic, Poland, have joined the project in terms of developing certain electronic subsystems. It is planned to launch the device into space orbit in 2021. At the same time, the designers work on the fourth Polytechnic, whose main task will consist in conducting biological experiments in space. How long can plants live in outer space, and what changes may happen to them? This work is carried out jointly with the Institute of Botany of the National Academy of Sciences. The purpose of this mission is to elaborate technologies for growing food for astronauts in space. The fourth satellite, Biosat, is designed with the purpose to grow plants that can be used in long-distance space program. The fourth satellite, Biosat, is designed with the purpose to grow plants that can be used in long-distance space projects, in particular for Ukraine's lunar programs and possibly international programs. The project is unique, so it is recognized by space agencies not only in Ukraine, but also in Spain and China. We are encouraged to go on with the work started, and probably these countries will provide support to the project. The fifth KPI nanosatellite, Gravasat, will investigate the Earth's electric and magnetic fields, as well as the characteristics of terrestrial cataclysms, earthquakes, or tsunamis. The unique equipment for space research developed by scientists will save millions of lives on Earth. It will be possible to predict an earthquake 24 hours before it starts. The plasma propulsion located in the center of mass allows us to keep the cosmic apparatus at the point which is optimally distant from neighboring cosmic apparatus. This is the spherical tank for the placement of plasma working medium. This is xenon. This is the plasma engine. In this module, we have the lithium-ion battery, which is used in case of peak energy consumption. On the basis of Gravasat, it is planned to create devices intended for far interplanetary space studies. The satellite will be able to remotely measure comets' mass. This is also one of the priorities for mankind's challenges. We hope that this technology will be in demand. In this sphere, we really are ahead of the rest. The successful launch and development of nanosatellites became possible thanks to the unique university material and technical base. KPI organized a special laboratory for testing small-sized spacecraft. These unique chambers fully simulate cosmic darkness, cold, and vacuum in laboratory conditions. There are no analogs in any Ukrainian university.
Наличие двух камер позволяет нам...
Two chambers allow us to test affordability of satellites and cosmic technology that are needed for experiments in outer space and for flight testing of new equipment. These are the chambers with volume of 0.12 and 2.5 cubic meters. In this laboratory, scientists test not only their prototypes, but also those of their foreign colleagues.
Эти камеры были использованы для...
These chambers were used for testing a solar battery for the University of Italy in Rome. We also tested heat pipes of the Bird spacecraft designed by the German aerospace company. We tested the scanners and payload for GIPSAT, in particular, for the Ukrainian-Egyptian GIPSAT-1 project. Microsatellites. In the Storm Design Bureau at KPI, satellites are also created, but they belong to the micro class. Microsatellites are special-purpose spacecraft weighing about 100 kilograms.
Перед вами масштабна
Here is a scaled model of a microsatellite. Its base is a hexagon. Its height is about 800 millimeters. The main diameter is about 700 millimeters. When the satellite enters open space, the main systems automatically begin to unfold. These are, for example, solar panels, and they are 6. There are systems of magnetic orientation of magnetic measurements. They are combined together with the antenna system of telemetric information. There are also 2 main antennas of the high-speed radio channel, which will provide transmission of big data with a channel capacity of up to 400 megabytes per second. On board the microsatellite, there are power supply systems, battery. There are also star tracker systems for navigation and magnetic field positioning system, as well as inertial positioning systems. And, more to the point, the satellite's eye is an optical scanner.
Він представляє собою відкриту систему.
The scanner is an open system that consists of the primary mirror with a diameter of 400 millimeters, secondary mirror of 200 millimeters. The secondary mirror fixing system made on the power technology basis using 3D printing, an electronic system which consists of the charge-coupled device matrix and its operational electronic units.
Електронні вузли і
Scientists gave up on the classical platform system when creating devices of this class.
все будується навколо оптичного
The optical scanner is the core of the structure. In fact, it is both a platform and an object that provides us with relevant optical information from space. Moreover, each system on board is duplicated, so there is a backup solution for any emergency situation. Both the housing of the satellite and the scanner itself will be made of an ultra-strong, ultra-lightweight, and high-temperature ceramic material. Such material is also invented by KPI.
Розроблено керамічний матеріал.
A ceramic material has been created that can be used under outer space conditions. Satellites must withstand high enough temperatures, up to 1600 degrees, as well as dynamic load. There is a system of optical mirrors. It is fixed on the frame. The frame must be of high strength and rigidity. Its coefficient of thermal expansion must be low, and all these conditions ensure the efficient operation of the entire system. That is why reinforced titanium alloys, which were developed at our institute, were chosen as the material. Using 3D printed technology, samples of material were designed and produced that have a unique cellular structure, low weight, and ensure high strength and rigidity. The university also creates formations of surveillance satellites for remote sensing of the Earth for civil and defense purposes.
мова йде про досягнення.
This is about achieving ultra-high resolution when studying objects from a spacecraft. We plan to create, first, the microsatellite itself with such a resolution, and then the whole formation.
А потім і ціле групування.
Furcated satellite. Cheap, high-speed satellite internet from OneWeb and SpaceX will become a reality soon and cover the entire planet. KPI scientists have their own version of available satellite communication, and also the Internet of Things. They have developed furcated satellite technology. It is provided by the innovation that the payload of one apparatus will be distributed among the groups of micro and nanosatellites of the CubeSat format.
Сама ідеологія розгалуженого
The
супутника
very ideology of a bifurcated satellite, branch satellite, makes it possible to place telecommunication facilities in orbit and also to deploy a network of computing satellites in space that will work like an extensive computer network located in space. Taking into account that this network is very close to a user, it takes only 10 to 20 milliseconds to transmit a radio signal from Earth to such a satellite. It means that the owner can control his smart house from anywhere in the world, and self-driving cars will receive an uninterrupted signal even in an unpeopled desert.
ми порахували, що
We calculated the number of satellites needed to provide services at latitudes up to 63 degrees north and south, where most people on Earth live. We need about 2,500 of these small satellites. This is even less than SpaceX plans for its system. The system will function thanks to the so-called gateways that will tie a space segment to a ground one. Satellite Earth stations. High-speed transmission of big data from a satellite to the Earth is another sphere in which KPI works. For over 20 years, under the leadership of Professor Fedor Dubrovka, we developed unique terrestrial antenna complexes of satellite information systems for the whole world.
Ми будуємо професійні антенні системи.
We build professional antenna systems. Antenna sizes vary from 2 to 25 meters. We have developed new irradiation converting modules and counter reflectors for larger reflector antennas. We have actually implemented them, and Ukraine even exported them to Russia, Kazakhstan, Germany, and Italy. We developed antenna systems even for the USA. In the laboratories of the Institute of Telecommunication Systems, researchers work on a monopulse communication system intended for fast transmission to the Earth of information from the Earth remote sensing nanosatellites.
Це моноімпульсний опромінювач.
You can see a monopulse feeder. This is the small but precious component of the system. It operates on higher types of waves and allows to track the satellite in orbit with high accuracy up to 1 arc minute. Scientists have already made some preliminary studies and plan to create a domed multi-beam phase antenna array. It will receive information from hundreds of satellites at once and will replace hundreds of reflector antennas. Heat pipes for spacecraft.
Без наших труб он мог бы
The satellite could fly without our heat pipes, but the program might not have been fulfilled. It was necessary to guarantee temperature conditions for this device so that it would not overheat and deteriorate before the mission even starts. This refers to heat pipes, highly efficient heat transfer devices designed by specialists of the Faculty of Heat and Power for the Mascot Space Module. Mascot spacecraft is a project of engineers at the German Aerospace Center and the French National Center for Space Research. The spacecraft was launched into space in 2014 to study the asteroid Ryugu. It successfully finished its mission in 2020.
бельгійці і
The Belgians and the Spaniards were unable to make the needed construction for a year. Then we began to design internal capillary structures, selecting the necessary coolants. For the spacecraft, it was necessary to design a heat pipe of a certain size, configuration, and mass, but with variable thermal resistance. During the entire 6-year period of flight, the pipes were not supposed to transfer heat.
ці трубки должны
The weight of these pipes was not to exceed 100 grams. We managed to do all
нам
this.
удалось це зробити.
More than a half century back, the development of heat pipes with a metal fiber porous structure was initiated at KPI.
Пористость 90%. Это значит,
If the porosity is 90%, this means that it contains 90% of air and 10% copper. It is a capillary structure, similar to felt, but metallic one. The metal may be copper, nickel, iron, and so on. If we drop, say, alcohol or water, then this liquid will almost instantly begin to rise in the upward direction due to capillary forces. The design of heat pipes is based on this principle. When evaporation occurs here, steam moves this way. It condenses here and moves along the capillary structure towards the heating zone. Thus, the circulation ensures high thermal conductivity. Collaboration with the Pivden Design Bureau. Kyiv Polytechnic collaborates closely with the Pivden Design Bureau. MK Yangel Design Bureau Pivden is the leading enterprise of space industry in Ukraine. It ensures full cycle of development and operation of rocket and space technology. It occupies one of the leading positions in the world space market, participates in the implementation of NASA projects.
На замовлення цієї організації
By order of this organization, we have produced a number of devices whose concept is based on the use of so-called heat pipes. This refers to the EgyptSat project, a satellite ordered by Egypt, several designs of the Sergiy spacecraft, and others. Some designs of Kyiv Polytechnic are really unique, so that it significantly complicates any creation of their analogs.
сенсори навігаційні на нових
Navigation sensors based on new physical principles for rocket and space technology. Reused water purification systems in confined spaces of spacecraft are unique solutions. Another example is the simulator software, which became an integral part of the Energy Buran project and was also created by our scientists. The horizons of international cooperation at KPI are widely opened. Our scientists work together with international experts on a new generation of spacecraft.
Римський університет створювався.
The University of Rome was creating its own satellite. They turned to KPI for help and asked us to provide a power supply for their satellite. The University of Rome was creating its own satellite. They turned to KPI for help and asked us to provide a power supply for their apparatus. Another example relates to Germany. Our results are an integral part of the BIRD satellite. Our specialists from the Faculty of Electronics participated in the creation of solid-state transmit receivers, which were used in the Mars Curiosity rover project in the United States. So, there is a small part of KPI on Mars. KPI is an ongoing participant in international projects, in particular the Horizon 2020 project. Horizon 2020 is the European Union's largest framework program for science and innovation funding, with a total budget of around 80 billion euros. The aim is to expand the European research network. In particular, it is planned to build in Ukraine a ground station to transmit a GPS signal from space. This data is of great practical importance. Precision farming using remote sensing of the Earth will increase crop yield, and improved coordinate accuracy will improve aircraft navigation systems. Europeans are also hunting for dangerous cargo protection ideas, and that's where KPI could realize its potential.
Ми розглянули
We
можливість
analyzed the
застосовувати
possibility of using
різні
different chipsets
чіпсети,
in order to control
щоб
gas
фіксувати витік
outflow.
газу.
In 2021, KPI targets a new Horizon project. This is an ambitious EU research and innovation program. This program shall be launched after the successful implementation of Horizon 2020. Such issues as smart cities, adaptation to climate changes, improving people's health are among the principal goals of the new project. The gained experience gives many advantages to Kyiv Polytechnic. KPI has specialists in almost all branches. We are multidisciplinary, and we could offer far more favorable conditions to the consortium than others. KPI's space program is focused on the future. In fact, our university is proud of its intellectual and innovative potential.
Космічні дослідження є одним з головних пріоритетів.
Space research is one of the major priorities of KPI. We create integral designs, integral satellites, which are launched into space and are used for cosmic research of immense complexity. We suppose that it is a very important mission to go on with cosmic research in order to harness it for the betterment of mankind and our country.